Hello everyone, it's Professor Winson here giving you a video on Newton Alta assignment section 1.5 part 1 titled Factor Quadratics. Alright, so this video is going to be a kind of an introductory video on how to work in a Newton Alta assignment. Now first off, here I am in your Canvas page for this course. I'm in section 1.5, so I go down to that page, or to get to the assignment quickly as well, you can go to the assignments menu and go to section 1.5 part 1. But no matter how you do it, you have to open up these Newton Alta assignments through Canvas. All right, you can't open them up in Newton's website directly, okay? So I go to the review section 1.5, and again you got the title, the objectives, a link to the textbook, or you can read through the textbook here once it actually loads. And then there should be some videos on certain topics, certain objectives from section 1.5 of the openstacks.org. Again, they're not loading too quickly here. I apologize for that. Anyway, the most important thing about this, what I'm trying to show you in this way, is at the bottom. See, all the videos are coming up now. Homework with Newton Alta. And I'm going to show you, what one of these things looks like and how to work on them. So section 1.5 part 1, again you can enter it here or in assignments, the assignments menu. So once you click on one of the assignments, it's going to ask you to open it in a new window. And you click on this. Now I already have that window. Now I'm in teacher mode. Of course, you're going to see something different as a student. And it'll take you to Newton Alta. And if you haven't purchased access to the course yet, you're going to be asked to do that. All right, but I'm not. This isn't a video about purchasing access, right? You should have hopefully seen my introductory video to the course on how to do that. Alright, so let me just show you what the assignment will look like for you as a student. So I'm in a preview. Alright, you will not see the word preview. You'll just see section 1.5 part 1, factoring quadratics. You'll see the title of the assignment. Alright, then in the upper right hand corner you have this mastery bar, which you can see right now. It says assignment mastery 0% because I haven't really done anything yet. This is just telling you how far along you've gotten, what percentage you'd currently have if you were to, if the course were to end today, right? Now, I'll tell you this right now, you do not have to get this to be 100% to move on to the next assignment, right? All the assignments are open up to you right now. You can do any one at any time. And you can keep working on them until you get the percentage that you want. Now, if it's 100%, great. You're going to see that 100% show up in your Canvas gradebook right away. Now, if you only get to like 70 or 80%, you're not going to see that right away. You won't see the score show up in Canvas until you finish it, or until you get 100%, or until, the due date comes, which, remember, the due date is the last day of the semester here. So just keep that in mind. Alright, then beneath that you see a question, and above this, it tells you what objective that question is about. So the current objective is, factor a trinomial. And there's this little down arrow button beneath that where you can click on this and see all the objectives for this assignment. And it looks like there are 3 objectives. Right, there's factor a trinomial by grouping, factor a trinomial, and factor the greatest common factor of a polynomial. And each of these has a little star and a circle around it. These are progress bars for that particular objective. So you're going to see as I go through and get more and more questions correct, these circles will fill up, and once it's filled up, the star will show up and you'll know you're done with that objective. It'll also inform you when you're finished with an objective. Alright, so I have this question, factor the following trinomial, x squared plus 5x minus 24. Now, you're going to see some buttons at the bottom. Now, there's this feedback button, which you'll be able to click on and submit feedback to Knewton. Tell them if there's any issues you're having with the question. This instructor cheat button you will not see, right? This is for me only. You will not see this because this is going to, this is filling in the correct answer. But you will see this button, and this is a very important button, this one right here, more instruction. All right, so let me show you how this works. So say you're trying to work on a problem in a particular objective and you're struggling, or you don't remember what to do. You've gone through the reading, you've watched some videos, and maybe it's been a bit and you forgot. You can click on more instruction, and it's going to ask you, go back or view instruction, and it's going to be instruction related to that objective that you're currently on, right? Factoring a trinomial. So I click view instruction, and here is some reading. Now there may be some reading or some videos or both related to that particular objective. So read through, take notes, practice whatever they have, look at their examples, how to do things, and then after you've read through, you hit continue and it throws a question at you related to that same objective. Now this one's nice and multiple choice, but let me actually write this out and we'll talk about how to factor it. So let me go, I got some paper here, let me write that out. So the polynomial we're given, right, this trinomial, it's got three terms, is x squared minus 7x plus 6. All right. Now we're asked to factor this, right? Factor just simply means rewrite it as a product, right? Rewrite the expression as a multiplication problem. Right? What times what would give me x squared minus 7x plus 6. All right, well, I'm going to go over real quickly here how to factor a trinomial of the following form: x squared plus bx plus c, right, where the lead coefficient is 1. I'm going to point that out too. What I'm about to discuss with you is only going to work for polynomials of this form when the lead coefficient is 1. So first step is just, you're going to, all you need to do is find, if you can, find, if possible, a pair of factors. I'll call them P and Q. A pair of factors of C, right, the constant term, whose sum is B, the linear coefficient, meaning that P times Q equals C, and at the same time P plus Q equals B. Then you can factor, x squared plus bx plus c will factor to x plus p times x plus q. It's very simple when the lead coefficient is 1. And that's all. Then factor. Now, if for some reason you can't find this pair of factors of c whose sum is b, then it's just not factorable. Right? You just say it's a prime polynomial. Alright, so something we can do here is I'm going to make a little table. Now if you see them already, go ahead and finish it, but I'm going to make a little table with factors of 6. The constant term, the value of c is positive 6 here, and their sum. Now I would like the sum of this pair of factors of 6 to be negative 7. Right? The b here is negative 7. So two numbers that multiply to be positive 6 but add up to be negative 7. Well, how about negative 1 and negative 6, right? Those, and they have to both be negative, right, to make a product that's positive and a sum that's negative. So negative 1 times negative 6, that's positive 6, and their sum is negative 7. So yes, this is the pair of factors that I want. This negative 1 and negative 6 are the p and q that was discussed over here. So then very quickly we can factor x squared minus 7x plus 6 into the following. It's the product of x plus p, or plus negative 1, so just x minus 1, times, and then x plus q, or x minus 6. And then don't forget to check. I'm going to put this in a box here. This is our answer, our factored form of this polynomial. And then don't forget to check by multiplying. Right? The way you check factoring is by multiplying. Right? You multiply these two to FOIL, right? Distribute the x, you get x squared minus 6x. Distribute the negative 1, you get minus 1x plus 6, and then combine like terms, you would end up with x squared minus 7x plus 6. So this is correct, x minus 1 times x minus 6. And let's go back and fill in that was this, or x minus 6 times x minus 1, right? Multiplication of real numbers, the order doesn't matter. So this product here is the one we're looking for, and then I hit submit. It'll say, great, Now if you're wrong, it'll say you're wrong and give you probably another try. But if you're wrong a couple times in a row, it's going to throw another question at you, or more reading, more instruction. The thing about Knewton is, it's adaptive. So the more questions you get wrong, the more questions you'll have to do to complete and master the assignment. Master the objectives. So don't guess a lot. Don't, especially if you don't know, have no clue what you're doing, because the more you guess and the more you get wrong, the longer things are going to take, and you could be here a while. So try your best to make sure you've read the book, you've read section 1, whatever section you're on in the OpenStax book, Algebra and Trigonometry. You've watched the videos provided, either my lecture videos or the videos I put up in the Canvas page. You've taken notes, you've organized notes, you've practiced examples and exercises from the text. You've done your due diligence. You've looked at more instruction in the Knewton Alta homework. Hopefully you've done all that stuff so that you know for certain what you're doing. And then you can get these questions correct and move on through the assignment more quickly. Right. Okay. So and then after every question, whether you get it right or wrong, there's an answer explanation. So if you get it right, I would still recommend reading through it just to make sure you understand why you got it right, or compare your work to their work and see how they compare. Now, if you got it wrong, definitely read through the answer explanations, right? Try to figure out why you were wrong, and then go back and next question you get with that objective, do it. Hopefully you do it better. All right, so let's continue now. And now you see I got one question correct in that objective, factor a trinomial. And here's another question with that same objective. And you see now the circle, how a quarter of it is filled up. So that looks like I'm a quarter of the way done. And let's try this one. All right, so I'm going to write this one out and do the same thing I did with the last example. All right, so this polynomial is x squared minus 15x plus 54. And again, it's one of those trinomials of that form that I had with the last example, x squared plus bx plus c. So I'm just looking for a pair of factors of 54 whose sum is negative 15. And again, you can make a little table like this, factors of 54 and their sum, and we would like a sum, of negative 15. So I want two numbers that multiply to be positive but add to be negative. So they need to both be negative. So I mean there's negative 1 and negative 54. Those multiply to be positive 54, but they add to be negative 55, right? So no on that. Negative 2 and negative 27, right? Those multiply to be positive 54, but they add up to be negative 29. That's not negative 15. 3 goes into this, right? Negative 3 and negative 18, right? They multiply to be positive 54, but they add up to be negative 21. Looks like I'm getting closer to negative 15, but we're not quite there yet. Let's see. 4 doesn't go into this. 5 doesn't go into this. 6 does, because 2 and 3 do. Negative 6 and negative 9, right? Those multiply to be positive 54, and those add up to be negative 15. Those are the numbers that I want right here. Negative 6 and negative 9. And being that the lead coefficient is 1, this very easily factors to simply x minus 6 times x minus 9. All right, and that's it. All right, using the two factors we had, and I'll put this in a box. And don't forget to check. All right, multiply these and make sure you get the same expression back, and you should. All right, so now I go back and enter that answer that we got. Now this one's not a multiple choice, right? We have to enter it ourselves. So put in parentheses, x minus 6 times, and then in parentheses again, x minus 9. And this should be good. And again, it doesn't matter what order you put factors in. X minus 9 times x minus 6 would be the same thing. And once again, if you're still struggling, you can always click on More Instruction. You can always hit that button. Okay, wonderful. All right, and then read through your answer explanations, please. Let's continue on. All right, so now I'm at another objective. All right, factor a trinomial by grouping. All right, so these will be polynomials where the lead, quadratic polynomials, where the lead coefficient is not 1. Right, you see this 3x squared plus 10x minus 8. And they're asking us here, which of the answer choices is a correct grouping of the following trinomial if you were to try factoring by grouping. Now, again, if you don't remember what factoring by grouping is, click on More Instruction and read what they have to say about it again, or watch whatever video they provide to you. Alright, but I'm going to go through here and, do it on my own piece of paper. Alright, so this polynomial, we have 3x squared plus 10x minus 8. Alright, so now we're factoring polynomials of the following form: ax squared plus bx plus c. Alright, so I'll show you the steps I would take here to factor this by grouping. Alright, so the first step is find the product a times c. Alright, what's a times c? So that's the lead coefficient times the constant. So that's 3 times negative 8. This is negative 24. Alright, so that's step 1. Find AC. Next step is just like earlier when we were factoring trinomials. I wish now to find a pair of factors if possible, find a pair of factors, if possible, of this AC, right, this A times C, this negative 24 here, whose sum is B. And again, I'll call them P and Q, so I want P times Q to be the same as AC, and at the same time, P plus Q to be B. So if I do a little chart again, we're looking for a pair of factors of negative 24 whose sum is 10, positive 10. Now if the number that we're finding factors of is negative, that means one factor is negative, one factor is positive. So like negative 1 and 24, right? But those add up to 23, so that's no good, right? I want a sum of positive 10. And how about negative 2 and 12, right? Those multiply to be negative 24, and they add up to be positive 10, so yay, right? Now, this is where it gets a little different. This is where that grouping comes in. Third step. Now, instead of just saying, oh, it's going to be x minus 2 times x plus 12, be careful with that. All right, this is not the same as x minus 2 times x plus 12. Right, because this would be x squared plus 10x minus 24, right? That's totally not the same as 3x squared plus 10x minus 8. So be careful when the lead coefficient, right? When the lead coefficient is not 1, you have to do a little more, right? You have to do a little more thinking, a little more steps involved. So here's where we rewrite bx as px plus qx. Rewrite that middle term using those two factors. So now we have, instead of 3x squared plus 10x minus 8, the plus 10x, I'm going to rewrite as minus 2x plus 12x using those two numbers. And then you have minus 8. And this is all they were asking us for. How would you rewrite the middle term to start factoring by grouping, right? So of all these choices here, the one that makes sense for grouping is this minus 2x plus 12x here in the middle. That's all they want. But if you were to continue on, then you do something called factoring by grouping. And it's pretty simple, I feel. Where you take, you have this polynomial now. It started off having 3 terms. Now it has 4 terms. And you cut it in half. You break it into 2 groups. So I put in parentheses the first 2 terms, 3x squared minus 2x. And I like to put a big plus sign. And then in another set of parentheses, another group, the second 2 terms, which is positive 12x and negative 8. And then you factor each group separately. Right. So the first group, 3x squared minus 2x, those have a common factor of just x. So I pull x out. And if you pull x out from this first half, you have 3x minus 2. Alright, if you were to redistribute x, you'd get 3x squared minus 2x, right? Plus, and then the second group, the 12x minus 8, their greatest common factor of these two terms is 4. Right, and if I pull 4 out, I'll have the same factor remaining, 3x minus 2. Right, that'd be 12x minus 8. And then finally factor the whole thing. Right? If you look at these two terms, they both share this 3x minus 2. So you factor that out. Right? 3x minus 2 comes out. And then once you remove that, it's almost like reversing the distributive property. The factor that remains is x plus 4. And there we go. This is how you would factor that polynomial. Right? 3x squared plus 10x minus 8 factors to 3x minus 2 times x plus 4. And don't forget to check. actually multiply these, distribute the 3x, distribute the negative 2, and combine like terms, you'll end up with 3x squared minus 10x, or plus 10x minus 8, I promise you. But this thing here, though, right, this is what they had us enter, how you would set it up, factoring by grouping. Alright, so then I submit. Wonderful, and again, please read through the answer explanations. Hopefully those make sense and are clear. Then they ask, then part 2 of this, see, they actually ask you to factor it, so I'm glad I continued on there. Right, those two factors were 3x minus 2 times x plus 4. And there you go. I just enter my product and submit, and it should be good. And once again, read through the answer explanations, please. Alright, let's continue on. Alright, so now we're back to this objective that we haven't started yet, right? Factor. Now I've already kind of done this a little bit, factoring out a common factor, right? From that 3x squared minus 2x, I factored out an x, and from the 12x minus 8 in the previous example, I factored out a 4. This is just factoring out, something that's a common factor to all the terms of a polynomial you're looking at. So factor the greatest common factor of a polynomial, or for short, it's called the GCF. That's greatest common factor. Alright, so that's just the largest expression that, goes into all the expressions, all the terms you're given at the same time. Alright, so I'll show you a quick way to, they're telling us here, again, if you want to see more about this, you don't remember, you did your reading and all that, practicing, watching videos, taking notes, practicing problems, and you're still having trouble, you still don't remember what to do here, click on More Instruction. In fact, I highly recommend going to More Instruction for every new objective. Every time you see a new objective, it can't hurt to see more instruction. Okay, so the terms we're given are, 57x cubed y to the 5th, 51x cubed y, and 63x squared y squared. Alright, so I'll write these out on paper. So yeah, 57x cubed y to the 5th. Then we have, 51x cubed y, 63x squared y squared, and we're asked to find what's called, the greatest common factor, or the GCF, right? So how do you find the greatest common factor of expressions or terms of a polynomial? Well, one is to factor each expression completely. Alright, so like 57. 57, when you factor it completely, that's, 3 goes into this. 19, this is just 3 times 19. So if you were to factor 57 completely, 3 times 19, those are prime. And then, x cubed, I guess you could write it as x times x times x. I'll show you a shorter way in a second. And then y to the 5th is, y times y times y times y times y. Alright, there's 57x cubed y to the 5th broken up completely into the product of all its prime factors. 51 is 3 times 17, and then x cubed is, x times x times x, and then y to the 1st, right, times y. And 63 is 9 times 7, which is 3 times 3 times 7. Okay. And then x squared is x times x, and y squared is y times y. And then you're just looking for what's common what's a common factor in all three of these terms, and that's going to make up the product of those common factors is going to make up the greatest common factor of all of them. So I notice there's a factor of 3 in all of these. So there's going to be a factor of 3 in the greatest common factor. 19 in this, but no 19s in these. There's another 3 here, but no more 3s there. There's a 7, there's a 17, but that's not shared by all of them. They all have 1x, right? They all have a factor of x. So there's a factor of x in the greatest common factor. They all have another factor of x. Right? So they all have at least 2 factors of x. So there's going to be 2 factors of x in the greatest common factor. Now this first one has a third x, this has a third x, but the third one does not. So they don't all share another factor of x, right? So that's it for the x's. I don't know why I put y times y squared here, sorry, y times y. Alright, then we have a y in all of them, and that's it. That's it, right? Those are all the y's they all share. So the greatest common factor would be 3 times x squared times y to the first. Okay. So that's a long way of going about it. I think the short way of going would be to factor completely. Right, so this first way is 3 times 19 times x cubed times y to the fifth, and just keep powers. Same thing here, this is 3 times 17 times x cubed times y. This is 3 squared times 7, then times x squared y squared. And then again, go through what's common. Right, they all have 3 to some power in common. And then what's the lowest power on the 3? Right, and that's what you're putting in here is the lowest powers on the common factors. Right, because for all of these, there's 3 of the first, 3 of the first, 3 of the first, 3 squared, but the lowest of those is 3 of the first, right? So that's what's going to be a factor in the greatest common factor. And then each one of these has x to some power, right? X cubed, x cubed, x squared. The smallest of those powers is x squared. So that's going to be the power you see on x in the greatest common factor. And they each have y to some power, y to the fifth, y to the first, y to the second, and the lowest of those is y to the first. Right. So you just, again, factor completely, and then just what do they all have in common to the lowest powers on what they have in common. Right. All right, and this is what I'm going to enter. Right, going back to the exercise, right, this is just 3x squared y. Right, 3 times x squared times y to the first. Very, very simple. And it's like, great, hooray. And once again, please read through the answer explanations. It's pretty short, this one. Okay, and then we got another one. Now this is, factor the greatest common factor of a polynomial. So here we are asked to factor the GCF out of the following expression. Now factoring the greatest common factor out of an expression is just reversing the distributive property. Alright, so I'm assuming you know what that is. So it's just reversing the distributive property. And you'll see when I write it out. And write your answer in factored form. Alright, so again, I'm going to go to my paper and write out this problem here. The polynomial we're given is, 91 x to the 10th plus, and then 39 x to the 5th, right? So the terms, right, the terms of this polynomial are just the products that are separated by sums, right, or differences, but minus signs are actually part of a term. So the terms here are 91x to the 10th, and then there's a plus sign, then you have another term, 39x to the 5th, and then I'm just doing what I did in the previous problem. Let's find, the greatest common factor, right? Find the GCF of these two terms. Okay, so 91x to the 10th, And 39, let's see, 91. Trying to break it up. Let's see, 2 doesn't go into that, 3 doesn't go into that, 5 doesn't go into it, 7 does. That'd be 7 times 13. Right, 7 times 13 is 91, and those are prime. And then you have x to the 10th, right? And 39 is 3 times 13, and those are prime, and then times x to the 5th. Right, so I've factored both terms completely, and so now I should be able to form the greatest common factor. Let's see, they don't have a 7 or 3 in common, but they do have 13 to some power in common, right? And the lowest power on those is 13 to the first. So they both so the greatest common factor has a factor of 13. And then they both have x to some power, but the lowest of those powers is 5. Right, so that's going to be the power on x in the greatest common factor. Right? So 13x to the 5th. So when factoring this polynomial here, when I factor out the greatest common factor, I'll write the GCF, 13x to the 5th, times, and then in parentheses, what would be left over if I remove this factor from these two terms, right? So that's what I meant by reversing the distributive property. Think about if I were to distribute 13x to the 5th, what would need to be in parentheses so that I get 91x to the 10th plus 39x to the 5th back. So 13x to the 5th times what would be 91x to the 10th? That would be 7x to the 5th. Right? 13x to the 5th times 7x to the 5th would be 91x to the 10th. And then you got a plus, right? Plus, plus. And then 13x to the 5th times what would be 39x to the 5th? Well, that would just be 3, wouldn't it? And then close the parentheses. And this is what they wanted, right? They said factor out the greatest common factor, and then write your final answer in factored form as a product like I have here. All right. And that's what I'll type. So going back here, go to the blank space. We got the GCF 13x to the 5th pulled out, set of parentheses, and then times the quantity 7x to the 5th plus 3, and close parentheses. And this product, and again, if you want to check that this works, multiply them. Distribute the 13x to the 5th and see that you get this back, and you should, and it does, and it works. Great. And again, please read through your answer explanations. Alright, so now see it bounces around to different objectives here. We're back to that factor a trinomial objective where the lead coefficient of a quadratic trinomial was 1. So I'm just going to talk this one out. I already did 2 of these on paper. When the lead coefficient is 1 like this on a quadratic trinomial, you just need to find factors of the constant term that add up to the linear coefficient. Like, what are two numbers that multiply to be negative 20 but add to be negative 1? Alright, and you can go through different pairs and whatnot, but it's negative 5 and positive 4. And so this very simply, because the lead coefficient is 1, it factors to x minus 5 times x plus 4. Right, one with the negative 5 in it and the one with the positive 4. And again, you can check by multiplying these and see that you get this back. And submit. Again, please read through the answer explanations. Make sure things make sense to you. It looks like I got just, it's been going a quarter every time. Looks like I got just one more question. And once again, it's one of those where you have a quadratic polynomial where the lead coefficient's 1. So all you need to do to factor it, if you can, is find factors of the constant that add up to the linear coefficient. So what are factors of 5? That add up to 6, and that would just be positive 5 and positive 1. So this will factor to, the quantity y plus 5 times the quantity y plus 1. Now be careful, sometimes you'll accidentally think about putting x. Pay attention to the problem. This polynomial had y's in it, so your answer should have y's in it, right? Just make sure you're paying attention. Great, and see it says, once you're done with all the questions that you need, once you're done mastering an objective, it'll tell you. See, hopefully you saw that message there. It said, way to go, right? You completed one of the 3 objectives. And read your answer explanations. Alright, so now we're back to the factoring the greatest common factor of a polynomial. And again, I've written out a couple of these. This one is factor the GCF out of the following expression. Write your answer in factored form. So 45, 33, and 78. Let's see, have 3 in common. This is 3 times 3 times 5. 3 squared times 5. This is 3 times 11. And this is 3 times 26. Yeah, so 3 times 2 times 13. Yeah, the only factor they all have in common is 3. So 3 comes out, and then they all have x to some power, but the smallest of those is x squared. So 3x squared. And then they all have some power of y in common, but the lowest is y to the third, right? So the GCF, the greatest common factor, is 3x squared y to the third. Alright, then there are 3 terms here, so there are going to be 3 terms in a set of parentheses, so that when I redistribute the greatest common factor, I get this back. So 3x squared times y cubed, times what would give me 45x to the 5th, y to the 7th. Well, that would be 15x cubed, y to the 4th. Alright, and then plus, and then 3x squared y cubed times what would give me 33x cubed y cubed. That'll just be 11x, in that middle term there. And then finally 3x squared y cubed times what would give me 78x squared y to the 4th. That'd be 26 y, right? And then close the parentheses. And again, double check it. Make sure when I redistribute, when I multiply these, I get this polynomial back. All right. And yeah, looks good on my end. All right, so I'll hit submit. And great. Again, read through your answer explanations. Alright, looks like the last problem here. Now again, I'm doing 4 because I'm getting them right. If you get every question right, you should be doing at most 4 problems per objective. If you start getting stuff wrong, the progress bar will back up a bit, so you'll have to do more questions to finish it up. Let me just, again, so that's why I was saying earlier, don't just be guessing on these things. Alright, and then this one's just simply, if these were 3 terms of a polynomial, what's the greatest common factor? Alright, what's the greatest common factor? Alright, so you know what? This one I'll actually write out because, well, no, actually, kind of alright. This is 2 times 3 times 13, right? 78. 6 times 13. 2 times 3 times 13. This is 3 times 13, so they have 3 times 13 in common so far. And then 84 is 4 times 21. That'd be 2 times 2 times 3 times 7. Yeah, so the only factor they have in common is 3. The numbers, anyway. Alright, again, this is 2 times 3 times 13. This is 3 times 13. And this is 2 times 2 times 3 times 7. So the only thing that all the numbers share as a common factor is 3. And then all the terms have x to some power, but the lowest one is x to the first, so 3 times x. And then they all have y to some power, and the lowest power is the 4th, right? So 3x, y to the 4th would be the greatest common factor of those 3 monomials. Great. And again, you can write it on paper. Like, again, I did it for 2 of them already, so I'm hoping that just listening to me will help here. And then I should have just the one objective left. Alright, there were 3 objectives. Factor a trinomial by grouping. So here, which of the following answer choices? So again, I'm going to do that factoring by grouping method. This one I'll write out, right, because I've only written out one problem here. So let's go back to paper. So we had negative 1 times x squared minus 15x minus 54. And try the grouping thing. Remember, the first thing I did was take the lead coefficient times the constant, which is positive 54. All right, negative 1 times negative 54, positive 54. And then find factors of positive 54 that have a sum of negative 15, which are negative 9 and negative 6. All right. These multiply to be positive 54 and they add up to be negative 15. So the way I would rewrite the middle term is with these two numbers. So this polynomial we started with is equivalent to negative x squared, and then instead of minus 15x, I rewrite the middle term as minus 9x minus 6x, or minus 6x minus 9x. It doesn't matter what order, and then you have minus 54. All right. So of the choices we were given, so they have minus 9x minus 6x, right? So it's this second one here. Submit. And then they'll ask me to actually finish it off and factor. All right. So let's do that. Okay, so now the grouping part comes in. So the first two terms I'm going to put in a set of parentheses. And then again, I like to do this, put a big plus sign. And then in another set of parentheses, the next two terms, negative 6x minus 54. All right, now it's a good thing this kind of problem came up, because I do want to point out this note. When the lead coefficient of a polynomial you're factoring is negative, so I'll say when lead is negative, factor out the opposite of the GCF. Or negative GCF, if you will. Right? It'll make things that much easier for you, I promise. Right? So like in this first term, or this first group, the greatest common factor would be x. Right? They both have x to the first in common. But because the lead term has a negative coefficient, I'm going to pull out negative x. All right. And then once that's done, again, just we're factoring out the GCF from this first group. Imagine redistributing negative x. What would need to be in here? That would be x plus 9. All right. Negative x times x would be negative x squared. Negative x times 9 would be negative 9x, right? So we're good there. All right. Plus, and then the second group, the second set of parentheses here, negative 6x minus 54. The greatest common factor would be 6. All right. 6 goes both into 6 and 54. But again, because the lead coefficient is negative, I'm going to factor out negative 6. My little note here. When the lead is negative, factor out the opposite of the greatest common factor. And if I pull out negative 6, what will be left over in here is x plus 9. All right, and then finally, looking at the whole thing, this product has x plus 9 as a factor, and this product has x plus 9 as a factor. So I can pull out that common factor of x plus 9 times, and if I remove x plus 9, what's left is negative x plus negative 6, or minus x minus 6. You can write it that way. And you could have also said that negative 1 was here, right? Pull out negative 1 and make this x plus 6. If I pulled out negative 1 times x plus 9, what would have been left over would have been x plus 6. And either one of these is fine. Right? Either one of these is fine, as you'll see. I'm actually going to type this version when they say, factor it. And usually, no matter what you type in, as long as it's equivalent and to what you should be writing, they'll probably give it to you. So I'll put a minus sign and then in parentheses x plus 9. Right? That was the opposite of the GCF. Negative the quantity x plus 9, and then times x plus 6. And again, if you want to double check, multiply these two and then distribute -1, you should get negative x squared minus 15x minus 54 back. Great. And again, please read through now you see they had negative x minus 6 like I had earlier, right? Same thing. You could factor out -1 from this and get exactly what I wrote here, right? Or what I wrote here. Same thing. Cool. And that should be it. I finished all the objectives, and this is what's going to, obviously this is an assignment preview. You're actually going to be working on the assignment. It'll just tell you it's complete though. Right. Now, one thing else I want to say is please understand that the questions I looked at in this video, they're not going to necessarily be the same questions you see when you're working on the assignment yourself. But they'll be similar. All right, I mean, it's all the same objectives. So I'm hoping that watching me go through these examples here help you in some way, when you're asked to, do this assignment on your own. And I'm also hoping that watching me go through this and talk about, using more instruction when you're struggling or when you come across a new objective. I'm hoping watching me go through this helps you when you're working on really just any Knewton Alta assignment at all. And yeah, and thank you very much for watching.